Good evening. This is Tinawi, and I'm going to review an article that was published in Europe. The article goes by the title, The Influence of Hydropower Dams on the Composition of the Suspended Riverbank Sediments in the Danube, or Danube. Danube? I don't know. It doesn't matter. It's a river in Europe that connects Serbia, Bulgaria, and Romania. This article was published in a journal called Environmental Science in the 148th volume around 2007. It was published with a slew of other articles in related fields, such as hydrology, hydrogeology, geology, environmental engineering, environmental science, and water resources engineering. As you can see here, here's some of the articles. A lot of them are related to what I want to study personally. Geography is a very important part of this article, so we're just going to zoom in on Google Earth and find where the Iron Gate 1 dam is. This dam that we're looking at is the largest hydropower dam along this humongous river. There it is. Next, we are going to look at some of the tributaries. We're going to head west now and look at one of the tributaries known as the Sava, and that was a complicating factor, the fact that there's water being deposited in the stream flow in between dams, so that kind of complicated the study. The objective of the study was to show that sedimentation in a river reservoir during low flow conditions not only affects the amount of suspended sediments carried downstream over the dam, but also its chemical composition, i.e. the sediments. And we're going to explore that in just a moment. So humankind has known for thousands of years that damming a river has humongous effects on its stream flow. Also, it has effects on the water quality, and this is something that the study paid attention to. In general, damming a river decreases the water velocity, which will increase the deposition of suspended sediments. You could also see an increase in heavy metals as a result of that, and you could see that from the Iron Gate backwater zone. This study concluded that hydropower dams cause fractionation in the distribution of heavy metals in the bottom and suspended sediments, as well as a decoupling of the fluxes between these compartments. So the two compartments being suspended sediments and embedded sediments. Suspended sediments being floating in the water when embedded sediments are in the mud. So they have a huge impact on the transport of pollutants. This figure just shows where the Iron Gate Dam is and several other dams along the Danube and its tributaries. One thing that this study really paid close attention to is the grain particle size found in the sediments in the river. So they did something called a grain size distribution analysis, which is something that we do in civil engineering geotechnical work. They found that dams have huge effects on the clay content. So more clay gets suspended in the water after the confluence of a dam. So from that, they found that clays carry a lot of heavy metals. So because of the increased clay fractionation, which just means the average size particle of all of the grains, which is in the clay range, that carries more heavy metals like magnesium and lead, that increased after the dams, and it stayed turbulent in the water, suspended in the water, rather than embedded in river sediment under the mud. One of the objectives of this study was to explain the steep increase in heavy metals found in the Danube after the confluence of the Iron Gate Dam and in its backwater zone and reservoir. For this purpose, 30 sites between 795 kilometers upstream and almost 2,000 kilometers upstream were sampled. So this table shows all of those stations and which city it's near. It shows the discharge of water from those cities into the river, and it also shows things like pollutant load. Here we're taking a look at the grain size distribution found in both the suspended sediments and the embedded sediments. So we see that once the river passes the Iron Gate 1 dam, there is a steep increase in the clay fractionation and a decrease of the D50, and the D50 just represents the mean particle size out of all the different sizes of particles. So one of the implications of this is we're going to see an increase in pollutant load suspended in the water. And in fact, there's actually going to be a decrease in pollutants embedded in the river sediments because the dam makes it so all of that pollution, which is attached to the clay-sized grains, is going to be suspended in the water, and therefore it's going to be more mobile and easier to affect wildlife. This table shows the lead content and the potassium to gallium ratio. Gallium shows an excellent correlation with aluminum, so they could use it as a proxy for aluminum and several other pollutants, so that's why that ratio in particular is important. The aluminum, iron, and magnesium contents of sediments increased with the increasing amount of clays. The organic matter content of the suspended sediments showed a different behavior upstream of the Gabikavoko Dam than upstream of the Iron Gate Dam. That's just one interesting thing. The heavy metals cadmium, chromium, nickel, lead, and zinc showed similar distributions throughout the study. And here we could see the Iron Gate. You see there is a steep increase in the lead in the suspended sediments. I won't discuss it here, but this study used very sophisticated and rigorous analytical techniques in the laboratory and in situ along their different stations to look at the exact amount of different pollutants in the samples. And their in situ techniques were taken so they knew that they're not getting a bad sample. They were done to several high standards in Europe scientific institutions. So you could see the different chemicals outlined over here. They used various techniques like X-ray diffraction and so on and so forth. This study just reinforces what we already knew about dams, that dams do have many negative implications on stream flow and wildlife and communities served by those streams. It has negative water resources implications, and we could see this happening all over the world where one country will build a dam because they want renewable energy or they want independent energy, and then another country downstream has depleted water resources, and that causes agricultural problems and it causes sanitation problems. We could see this happening with Iraq. We could see this happening with Ethiopia, Eritrea, and Kenya. And yeah, so that just pretty much ties this study to renewable energy in general, and it shows that there are some implications that we have to consider moving forward. This study, more specifically, found the effects of dams on the grain size, particle distribution in the water, how the dams affect the particles flowing in the river, and that can lead to knowledge over how the pollutants are transported in the river and whether they're suspended or embedded. A couple of things that I wanted to point out about this study. So it was funded by the European Union. This article, in my opinion, there were some quality control things. I think that there were a few spelling and grammatical errors that I found, and as far as I could tell, this study was not translated. Also, some of the images weren't the highest quality. So we could see here, there's just one error. And also the table or the figure next to me that shows the map, it shows different backwater zones as the Danube travels in different directions and there's different stream flows. And you see it traverses several countries. The problem with this map is you could see there's like the border between Serbia and Bulgaria, and there's also the river. And the line weight of the river and the border is the same. So I don't know where the border of Bulgaria and Serbia is, or if it's the river or the border or both. It's kind of confusing. I feel like they could have put in higher quality images. But aside from that, I was very impressed with this study. It's related to what I want to do with my own career. I think it's extremely important, and I'd like to read more studies similar to this in the future, and I hope to see more of it.